Hello everyone, in this video we're going to learn on percentage purity. So this is the learning objective to calculate the percentage purity of a substance from an experiment or chemical reaction. Okay, so what is percentage purity? Firstly, why do we need to calculate the percentage purity? For example, do you know that the gold jewelry sold in the jewelry shop, they are not pure gold? Do you usually know that it comes with percentage number? That is the percentage amount of gold present in the jewelry. For example, most of the common jewelry used here in the market is the 91.6 or 91.7%, which is the 22K. The often one used here from the bazaar is usually the 18K, the Korean gold. Yeah, this is the amount of gold present in that jewelry. So yeah, the other percentage, which is often filled with other metal alloys such as iron to make it harder and also cheaper. Okay, so for example, in this scenario, you have a quartz with the mass of 28 grams. Then you go to the goldsmith to refine the gold quartz to collect the pure gold. After refining, you only got 6 grams. Alright, it's such a small amount. Well, this is true. It does happen actually in the gold shop. If you go change your jewelry to get the pure gold, yeah, you get lesser actually. So how do we calculate the percentage purity? So from 28 grams turns out to become 6 grams inside this gold quartz. So this is the formula which is in your notes already. Percentage purity is equal to mass of the pure substance in the sample over the mass of the sample, which is the total mass, times with 100. So for the previous case, so our percentage purity of the gold quartz is 6 grams, which is, this is the pure gold. This is the gold quartz, the one before you go to the goldsmith to refine. Then you multiply with 100. Then here you go, your answer must be in 3 sig fig. So that's basically how you calculate percentage purity. Alright, so here's our question. Page 11, exercise 10.9, question E. So how do we calculate percentage purity? Here's our case. When 6.5 grams of zinc containing impurities was reacted with excess hydrochloric acid, 13 grams of zinc chloride was obtained. Calculate the percentage purity of the zinc sample. So this zinc, actually this one, the 6.5 containing impurities, I've drawn a small diagram here. So you have impurities such as sand particle. So this whole thing is actually 6.5 grams including the sand, yeah, but not all of 6.5 will participate the reaction. Okay, only the pure zinc can react with HCl. Okay, as I written here, okay, only the pure zinc will react with the HCl. So the 6.5, we cannot use this value for our calculation, especially the ratio calculation. Do not put this 6.5 into the ratio calculation. Okay, firstly, how do we know how much of zinc has been used up for the reaction? So we know that our zinc chloride was formed from zinc, right? Only the pure one will give out this zinc chloride. So since we know the mass of the zinc chloride is formed, which is the 13 grams, so we can do the reverse way to find out how much of zinc was used in order to form this zinc chloride, right? So let's take these two for our calculation. Alright, this zinc chloride is purely produced from the zinc. Okay, so we're gonna take these 2 into our ratio calculation. So I have put it here. So let's start. As we recall from our previous lesson, so first row we always put our AR or MR. So the mass for zinc in your periodic table is 65, and here your zinc chloride, this one 65 plus 2 times 35.5 of your chlorine, then you should get 136. This is the AR or MR. Yeah, so how you gonna put your value into your calculation? All right, next, so our given value for this case is the 13 gram of zinc chloride. So this 13 gram we are going to put into our ratio calculation. So I'm gonna put here given value. This must be the pure value, yeah, not the impure. So we're gonna find the mass of zinc that has reacted with HCl to form zinc chloride. So we're gonna put here X. Now bear in mind, everything here is in gram. Okay, so everything here is mass. Now we have made sure that all the units are the same, even the column, they are in the same units, so we can safely cross multiply. So as usual, you cross multiply, you take the number also can, X times 136. So for this case, our 136 from the right hand side, you move to the left hand side, then you get X is equal to 65 times 13 over 136. So after you key in your value in the calculator, you get 6.21333. Okay, then you round off to 3 sig fig. Okay, nothing to add, so I leave the answer like that. Therefore you actually have 6.21 gram of zinc that has reacted. So actually, to recall my drawing here, out of 6.5 gram of this lump, only 6.21 gram of zinc exists, okay, in this lump. So how do we find percentage purity? So by using the formula percentage purity, so percentage purity is actually mass of pure zinc divided with mass of the sample, which is the lump, yeah, the impure lah, times 100. So you just put in the value 6.21 we got from our calculation, divided with 6.5 gram times 100%. Then you calculate 95.538 dot round off to 3 sig fig. Alright, okay, nothing to add. Lastly, our answer is 95.5%, 3 sig fig. Alright, sorry for the messy view, but in your note I will prepare a better, nicely organized written notes for you to read. Yeah, so here's the overview. Okay, Okay, to understand again the question, 6.5 is the zinc with the impurities. After reaction with HCl, you get 13 grams of zinc chloride. So this zinc chloride is pure, so we need to backtrack, go back to find out how much of pure zinc was reacted with this acid, yeah. So therefore we need to use the ratio calculation. Okay, first row, put in the AR or MR, get it from your periodic table. By now you should know how to pick this from your periodic table. Please don't say you forget how to do this. Okay, next, the given value must be pure. Do not put the impure one into your calculation. The 6.5 shall never ever put into the ratio calculation, only the pure one. So that's why your 13 gram of your pure product is here. So how much of pure zinc is actually reacted? So yeah, by using cross multiply, you have found out 6.25 gram of zinc. Then followed by the formula percentage purity, the mass of the pure divided with the sample, which is the impure, times dengan 100. So after that you do your calculation, then yeah, please round out the 3 sig fig, then there you go. Alright, here's our next question, question F. An impure sample of lead oxide was reduced to lead metal by an excess stream of carbon monoxide. So here's our chemical equation. If 400 gram of lead was produced from 446 gram of the impure sample, which is the lead oxide, yeah, I've highlighted this in orange so that you can see the color. What is the percentage purity of the lead oxide? Do you notice that I highlighted it differently? The impure one is orange, the pure one is in yellow. So our first step, you must know which one is impure, which one is pure. So our impure sample is the PbO. It must have mixed with something else. Then our pure product is the lead. This is the product, yeah. Let me write here. This is the reactant. So for this case, our product given is this lead. Our reactant we need to analyze is the lead oxide, PbO. Next, we need to, as usual, take these two to our ratio, PbO to the ratio Pb. Okay, next, our first row, we always put their AR, atomic mass, or MR, relative molecular mass, the molecular mass AR or MR from your periodic table. Okay, lead, the mass for lead is 207. The mass for lead oxide is 223. Okay, if you forgot to how to calculate this, this is actually 207 plus the mass of oxygen is 16, then you get this 223, yeah. So in the next row, you put your given value. This given value should be pure mass only. So the pure mass was produced is the lead. The product should be pure. Okay, the product should be pure. So we're gonna put this 400 into our calculation. So that's why we need to find out how much of lead oxide was used up from the impure sample. So we are doing backward lah, doing the reverse. So by using cross multiply, we can backtrack how much of lead oxide was used. Okay, do your ratio as usual, do your cross multiply as usual. 223 times 400 equal to x times 207. 207 bring to other side becomes divide. So 223 times 400 equal x over 207. Then now use your calculator to get the value. You should get 430.91 ... with a long answer, but round off to 3 sig fig. Yeah, 3 sig fig is here, so you need to add 1 to the other side, so you get 431 gram 3 sig fig. This is the mass of PbO was used up for the reaction. Out of 446 gram of the impure sample of PbO, 431 gram of PbO was used up for this reaction. Okay, this is the pure one. So how do we calculate the percentage purity? Percentage purity is equal to mass of the pure PbO divided with the mass of sample, which is the impure sample, yeah, then times 100. So your pure PbO is 431 gram divided with your 446 gram times 100. So you click in the values into your calculator, you get 96.636 ... round off to 3 sig fig. Okay, nothing to add. 96.6. Okay, 3 sig fig. Okay, here's the overall view. So identify the impure sample. The impure sample is usually the reactant, yeah. The impure sample usually the reactant, the starting material. So your pure product, this is what we're gonna use for the calculation here. The 400, put into your ratio calculation. So we're gonna find the pure PbO that was used up. So by using the cross multiply, do not forget your first row. You have to find the atomic mass or relative molecular mass, the MR, AR. Okay, so cross multiply, you get the value of this PbO. This is the pure. So therefore, put it into your formula, percentage purity. The pure of PbO divided with the mass of the impure sample times 100%. So insert the number, then you get the value. Please round off to 3 sig fig, yeah. So reminder, do not put the value of the impure sample into your ratio calculation. Okay, only put it into your percentage purity calculation. So let's go review what we have learned. Our keyword for the day is impure sample. The sample mixed with unknown substances such as dirt, sand, soil. The pure, okay, the only substance that exists in that thing or the object. Okay, the steps to success. First step, identify the impure sample, which is always the reactant, and the product produced. The product always pure. So use that amount of the product produced to calculate how much it was used up during the reaction. This is the reactant, yeah. The reactant was used up. So you have like this. If you notice, the formula, the template is memang like this. Reactant to the ratio of product. This is in the impure sample. So we must find the pure. Okay. So put the AR or MR or whatsoever from their periodic table. Calculate, yeah. Then the next row, the mass given. Usually the mass given is the product. Okay, the product is pure. So we put the number here. We are finding this. This X. We finding this X. How much of the reactant exists in that impure sample. Okay. See, I even put it here, the warning. Do not put the value of impure sample into the ratio calculation. You are finding how much of the pure exists in that impure. Okay, your product the mass they give is already pure, so you put here. Next, calculate the percentage purity. So this X, after you found the X, you put in into here the mass of the pure substance. Then the impure sample, okay, that one is given lah in the question, so you put in, then you times 100%, round off to 3 sig feet, and there you go. That's our lesson for the day. Thank you.